Assalamu alaikum. My name is Nida Ayub and today the topic of my presentation is MR materials. The contents that we will describe today are introduction, synthesis, surface modification, characterization, applications, recent advances, future direction, and references. MR materials. Microporous, mesoporous, and macroporous materials are collectively called MR materials. Depending upon their pore size, MR materials are characterized as microporous, mesoporous, and macroporous materials. Microporous materials have pore size smaller than 2 nanometer, and mesoporous materials have pore size between 2 to 50 nanometer. And the last macroporous materials have pore size larger than 50 nanometer. Microporous, mesoporous, and macroporous materials. Synthesis of microporous materials. The synthesis of microporous materials such as aluminosilicates and aluminophosphates are widely used as solid acid catalyst, ion exchanger, and in gas separation. Microporous materials such as silicate 1 and VSP5 can be synthesized by both microwave irradiation and conventional electric heating. Types and examples of microporous materials. Types: crystalline zeolite, which is also known as aluminosilicates, and activated carbons. Examples: metal organic frameworks, clays, AlPO4, which is also known as aluminophosphates, and carbon. Synthesis of mesoporous materials. Mesoporous materials are formed by a self-resembling process from combined solutions of sol and gel method and structure directing amphiphiles using block copolymers or surfactants. Soft template, which is also known as endotemplate, in which we use organic materials. Hot template, which is also known as exotemplate, in which we use inorganic materials. Examples: SBA15 and MCM41. Synthesis of macroporous materials. Synthesis of larger pores bigger than 50 nanometer of macroporous materials is an important and difficult stage of producing these materials. Traditionally, uploading agents such as carbon dioxide, nitrogen, or hydrogen peroxide must be added to the reaction to increase the pore size to create macroporous materials. Examples of macroporous materials: cupric oxide, nitric oxide, and zinc oxide. Advantages of MR materials. Microporous materials are low thermal conductivity, high thermal stability, flexible, environmental friendly, and mesoporous materials are nanopore size distribution, high surface area, and biocompatibility. And the last, macroporous materials. Macroporous materials are large soil pores, usually between aggregated, that are generally greater than 0.8 nanometer in diameter. Macroporous provide habitat for soil organisms and plant roots can grow into them. Applications of MR materials. Microporous materials have found versatile application, for example, catalyst, ion exchanger, absorbents, and zeolite. Mesoporous materials are very important in the removal of pollutants from water, absorptive xylene separation, separation of biological and pharmaceutical compounds, storage of gases such as methane, hydrogen, and carbon dioxide. Mesoporous materials. Processability of mesoporous materials, infused deposition modeling for drug delivery of thermolabile drug, morphology control, nitrogen doped mesoporous carbon vehicles for sustained release of paracetamol. Macroporous materials, fabrication of biofunctional macroporous absorption, resins through grafting carbon dot, and applications in the detection and absorption of iron. Highly permeable macroporous polymers synthesized from pickling medium and internal phase emulsion template. And these are the references. Thank you. Allah Hafiz.